Hi, welcome back. So now we're going to go through some examples of finding inverse matrices, and I'll do the examples and along the way show you some alternative methods for finding the inverse matrix. So for our first example, let's find the inverse if it exists for the matrix A equals 3, 2 is the first column and 7, 5 is the second column. So our method here is to augment A with the identity matrix, the 2 by 2 version of it, so 1, 0, 0, 1, and then we're going to row reduce. I'm going to do this first row reduction by hand just to give us a little review of that concept, but once we move on to larger matrices, I'll start using technology for the row reduction. So alright, we're taking A and augmenting it with the identity, so I'll write that here. And now we want to row reduce to get the A matrix to look like the identity matrix. That is, we want it in reduced row echelon form. So I'm going to start by trying to get that 3 into a 1 so that I have a pivot in that position. I'm going to take the first row and subtract the second row and make that my new first row. So I'm doing 3 minus 2 is 1, 7 minus 5 is 2, then I do 1 minus 0 is 1, and 0 minus 1 is negative 1. So my new first row is 1, 2, 1, negative 1. Alright, now I want to get a 0 in the second row below that pivot. So we're going to do the second row minus 2 of the first row, and that's going to become my new second row. So I'm doing 2 minus 2, that's 0, then 5 minus 4, which is 1, 0 minus 2, which would be negative 2, and then 1 minus a negative 2, so what's 1 plus 2, which is 3. So my new second row is 0, 1, negative 2, 3. Alright, so we're almost there. We just need to make that 2 into a 0. So to do that, I'm going to take the first row and subtract 2 of the second row. So I'm doing 1 minus 0 is 1, 2 minus 2 is 0, 1 minus a negative 4 becomes 1 plus 4 or 5, and then negative 1 minus 6 is negative 7. So my new first row is 1, 0, 5, negative 7. Alright, so we've done the row reduction. We now have the identity matrix on the left-hand side, and what's left on the right-hand side are the columns of our inverse. So our inverse matrix, A inverse, has the first column as 5, negative 2, and the second column as negative 7, 3. Alright, so this is our inverse matrix. You could also check your work by computing A times A inverse, or A inverse times A, and then make sure you get the identity matrix. But that's just another computation you could do if you want to check. The process we've already done gives us the inverse, and we should have our final answer. So because 2 by 2 matrices are so small, they have actually a shortcut that helps us find the inverse, so I'm going to give that to you now. So if we have a matrix A that looks like AC in the first column and BD in the second column, then the formula that gives us the inverse is that we take 1 over AD minus BC, and we take that and multiply it by this matrix, where the first column is D negative C, and the second column is negative BA. So we take the A and the D and swap it, and then we put negatives on the C and D. So this formula will give us the inverse for any 2 by 2 matrix if it exists. You'll know that it doesn't exist if you end up having that AD minus BC be 0, where you'd be dividing by 0. That wouldn't work, so then there wouldn't be an inverse. So if we go back to that example, and we have that matrix A that we started with, let's use this new formula and make sure that we get the inverse. So I'm going to do 1 over AD minus BC, so that's 3 times 5 minus 2 times 7. Then in my matrix, I swap the A and the D, so the 3 and the 5 swap, and then I put negatives on the C and the B. So we have negative 2 and negative 7. Now I just need to simplify. So on the outside, I'm getting 1 over 15 minus 14. That's 1 over 1, which is just 1. So we're left with 1 times this matrix, 5, negative 2 in the first column, and negative 7, 3 in the second column, and you'll see that this is exactly the matrix that we got with the row reduction method. So anytime you're trying to find a 2 by 2 inverse, you can use this formula, and if you want to see that this works in general for any 2 by 2 matrix, I'd suggest using this formula and going ahead and computing A times A inverse to show that it works and you get the identity. But I'll leave that to you if you're interested in working through the formal proof. For now, let's move on to some larger examples. So we're going to find the inverse of two more matrices if they exist. So we have this first matrix A. It has columns 1, 0, 0, 5, 1, negative 3, and 2, 0, 1. And then we have a 4 by 4 matrix B, which has columns 1, 0, 0, 0, 5, 1, negative 3, 0, 2, 0, 1, negative 2, and 7, 0, 4, negative 8. So to find these inverses, I'm going to use technology to do our row reduction so that we're not doing it by hand. You can use whatever technology you like. Maybe you know how to do some coding and you can do it that way. Maybe you have a graphing calculator. I'm going to use Wolfram Alpha. All right, so for our 3 by 3 example, we're going to take this matrix A and augment the identity matrix, the 3 by 3 version, to the matrix A. And then we're going to row reduce. So what I've done is typed out all of the rows into Wolfram Alpha, and I've asked it to do the row reduction for me. So when I do it, I'm getting the identity on the left-hand side. So A is reducing to the identity matrix. And then on the right-hand side, I end up with the first column being 1, 0, 0, the second column being negative 11, 1, 3, and the third column being negative 2, 0, 1. So, okay. I took A, I augmented the identity, and then I was able to row reduce and get the identity on the part of the matrix that is A, and I'm left with the inverse on the right-hand side. So this tells me that A inverse is equal to the right-hand side of this augmented matrix. And that'd be our final answer. Something you can also do if you'd rather not set up the whole row reduction in Wolfram Alpha is just ask it to find you the inverse. So you can say inverse of, and then type in the matrix you want the inverse for, and it will just give you the inverse. But it's nice to know that it's likely doing some row reduction behind the scenes. Okay, let's repeat this with the 4 by 4 example. So let's row reduce the matrix where we have B, that's our 4 by 4 matrix, on the left-hand side, and then we'll augment it with the identity matrix on the right-hand side. So I've typed that all out into Wolfram Alpha, and I'm going to ask it to do the row reduction. So you'll notice here, when we look at the left-hand side, what's happened after the row reduction is that we're getting something that's not the identity matrix. This final row corresponds to an inconsistent system where we're getting zeros equal to something that's non-zero. So when this happens and we don't get the identity on the left-hand side, this tells us that there is no inverse for the matrix B. That means B is not an invertible matrix. There's no inverse. So this problem doesn't have a solution. There is not an inverse for the matrix B. Moreover, if you try to ask Wolfram Alpha to do the inverse for you, so you say inverse of, and then you give it the matrix, it will tell you that the matrix is singular. So remember, singular means that there is no inverse. All right, so those are some examples about finding the inverse of a matrix. Our basic setup is to take the matrix and augment the identity, then do row reduction. But we also have a shortcut for the 2 by 2 case to make it easier on doing the computation. That's it for this video. Thanks so much for watching, and I will talk to you in the next one.